Hello there. So in today's lab, we're going to be accomplishing the different exam topics for 3.1, identify, configure, and verify IPv4 addressing and subnetting. I already have a lab ready to go for this one, so I'm going to open this one up. Okay. So as you can see in this lab, we have, we have 6 different routers, all using different private IP addresses. And we're just going to be establishing point-to-point connectivity with each of the links. So you'll need to know how to subnet to be able to complete this lab, but I'll show you everything. Okay, so if we start all the nodes, and then we'll go into R1. Okay, it'll take about a minute for the Cisco iOS to load. And we'll just open up tabs for each one of the other routers. So R2, R3, R4, R5, and R6. Here we go. Okay. Would you like to enter the initial config dialog? Always hit no. Terminate auto install, yes. We'll do that for each different router. No, yes. And then the first thing that I like to do is just configure the host names on each one of the routers. Okay, that's done. So we're going to start from R1 and then work our way through the topology. To establish full connectivity between each one of these devices, we could use a routing protocol like OSPF, but we'll be covering that later. So we're just going to establish end-to-end connectivity between each different node. So we're going to start with the serial link S1/0. We're going to go into the interface, add an IP address to it. So the topology says we should do 192.168.254.0. So in Cisco iOS images, I think it's like 12.4 and later, you're allowed to do this with the /31. Images before that, you would have to use a /30 because you would need the 2 other addresses for the subnet ID and the broadcast IP address. But in this case, this is a newer iOS image, so we don't need to do that. So we can do IP address 192.168.254.0, and then it's a /31, so that's 255.255.255.254, because we're turning on every single bit except for the last bit, because there's 32 bits. Okay, and it accepts the command, and then we can do a no shut to turn the interface on. And then we can do a write memory, or we could also do copy, running config, startup config. Or whoops, we just do this. Or you can just do write memory, but eventually that command's going to go away. So you should really be using copy, running config, startup config. Okay. So as you see, the interface goes down now. It's because the other end of the link is not set up. So let's tab over to R4 and set that up. So in S10, IP address 192.168.254.1. So there's only 2 IP addresses in this subnet ID, and then same subnet mask 255.255.255.254. No shut. Normally you would need to set up a clock rate on the DCE side of the interface, but since this is a virtual environment, you'll still be able to ping the two IP addresses without doing that. So let's see if it works. Ping 92.168.254.0. Success rate is 100%. And from this side, 100%. Okay, so that link is done. Let's go back into configuration mode and then interface mode in E00, and then it's 10.0.0.1, so this one's pretty easy. IP address 10.0.0.1, and then standard subnet mask, no shut, right memory. And now, so R1 is completely configured, so now we're going to head over to R6 and just work our way through. And then we'll establish E00, IP address 10.0.0.2, no shut. Okay, this link should be fine. Okay. So the reason the success rate was only 80% is because it has to do an ARP lookup, and with Cisco, pinging the timeout is a lot lower than other devices. So whenever you see 80% for the initial ping, normally it's completely fine. Okay, so we go back to R1. We'll just ping the other side and see it already has the ARP done 100%. Okay, go back to R6. Whoops. Okay, so the next one is 192.168.1.0 with a /25. So we'll do that. Okay, and then 255.255.255, and then one more bit, which would be 128. Okay, no shut. And then we'll just configure the other interface to E0/2, IP address 192.168.1. So we're using the same network address, but it's subnetted into two different sides. So the first IP address we can use on the second subnet would be 129. So we're going to do that. And 255.255.255.128. No shut. Save it, show IP interface brief. Okay, looks just like the topology. And now let's go over to R2, configure E0/1, IP address 192.168.1.2, 128, no shut. Okay, 80%, yep, ping it again, 100. Okay, that one's done. Let's go over to R2, and then we'll do the next one. So the address is 172.31.1.0 with a /28, and we're going to be using the second subnet starting at IP address .17. So if we do that, and this is at the end of the 172 private addressing, because it goes from 172.16 all the way to 31. So we'll do 172.31.1.17, and then 255.255.255, and then /28 would be 240. No shut. Okay. Let's see, this looks good. Now we'll go to R4 and configure the other side. Okay, so that one's done. Now we're going to see where we're at now, because that side is completely done. So we configured everything on R6, which means we're going to work our way to R3. And you can use the do command when you're in config mode to be able to do show commands. Okay, so everything's unassigned in R3. We're going to go into E00 and configure the other end of that link, 192.168.1.0. And we're going to be using the next IP address in the second subnet, which would be 130, and then 255.255.128. No shut. And let's see if we can ping. Yep, 80%, 100%. Okay, that link is done. Now we're going to do the other side of R3. And then it's going to be 172.16.1.0 with a /27. Okay. And these are just arbitrary variable length subnet masks that I chose just to make it a little harder to do. We could just be using all /24s if we wanted. Okay, so it's going to do that. And then 224 would be /27. Let's do a no shut. Okay, go into R5. It's just going to be the next IP address. Let's see if we can ping. 80%, 100%, and then okay, looks good. So there should be point-to-point connectivity on each one of the nodes, and then in later labs we're going to be using static routes and default routes and routing protocols like EIGRP and OSPF to establish connectivity between each IP address, including loopbacks and the entire topology. But to be able to do that with just static routes with this many routers, it probably wouldn't make sense, and you would most likely want to be using EIGRP or RIP you could use. But yeah, so that's the end of this lab, and thanks for watching.